Assalamualaikum and hi to Madam Akma. Okay, first, my name is Putra Danish bin HAZLY and my matrix number is 08 DEP21 F1074. I'm from class DEP3A and from Polytechnik Sultan Salahuddin ABDUL AZIZ SHAH in course Diploma in Electronic Engineering Communication. Okay, so today I want to present about Web of Things in Telecommunication Network DEP30083. Okay, next we go to the content. WOT in chapter 5, which is NGN service, in the subchapter Web of Things WOT. First we have introduction, second operation, third advantage and disadvantage, and lastly conclusion. Okay, we go to the introduction first. The Web of Things is a computing concept that describes a future where everyday objects are fully integrated with the web www. The prerequisite for WOT is for the things to have embedded computer systems that enable communication with the web. The Web of Things concept is to improve the interoperability, fragmentation, and usability of the Internet of Things (IoT). The World Wide Web Consortium (W3C) create a set of standards known as Web of Things (WOT). In order to enable device interaction, it is a subset of the Internet of Things (IoT) and is based on software standards like REST, HTTP, and URI. The physical device will either be accessed directly by end-user applications, which will be web clients like web browser, or indirectly through a WOT broker, which contains agents that enable an adaptation between the interface of physical items and web interface. Each WOT broker agent is focused on a certain interface, like Wi-Fi, Bluetooth, and others. We go to the legacy adoption. WOT architecture should allow mapping of legacy IP and non-IP protocols to web protocols supporting various topologies where such legacy protocols are terminated and translated. WOT architecture should allow transparent use of existing IP protocols without translation, which follow RESTful architecture. WOT architecture must not enforce client or server roles on device and services. An IoT device can be either a client or a server, both depending on the system architecture. The same is true of edge and cloud services. Okay, after that, we go to the operation. In operation, we have 7. First, component. Second, device. Third, applications. Fourth, digital twins. Fifth, discovery. Sixth, security. And lastly, accessibility. We go to the components first. Component. The use case help to identify basic components such as device and applications that access and control the device process that are located between device and additional component useful in some use cases in the directory, which assists with discovery. Thus, components are connected to the internet or field network in office, factories, or other facilities. Not that all components involved may be connected to a single network in some case. However, in general, components can be deployed across multiple networks. Second is devices. Access to devices is made using a description of their functions and interface. This description is called thing description (TD). A thing description includes a general metadata about the device, information models representing functions, transport protocol description for operating on information models, and security information. General metadata contains device identifiers (URI), device information such as serial number, production date, location, and other human readable information. Information models defines device attributes and represent device internal settings, control functionality, and notification functionality. Devices that have the same functionality have the same information model regardless of the transport protocol uses. After that, we have applications. Applications need to be able to generate and use network and program interface based on metadata description. Applications have to be able to obtain these descriptions through the network, therefore need to be able to conduct search operations and acquire the necessary descriptions over the network. Next, digital twins need to generate program interface internally based on metadata description and to represent virtual device by using this program interface. A twin has to produce a description for the virtual device and make it externally available. Identifiers of virtual device need to be newly assigned, therefore are different from the original device. This makes sure that virtual device and the original device are clearly recognized as separate entities. Transport and security mechanism and settings of the virtual device can be different from original device if necessary. Virtual devices are required to have description provided either directly by the twin or to have them available at external locations. In either case, it is required to make the descriptions available so that other components can find and use the device associated with them. After that, discovery. For TDs of devices and virtual device to be accessible from device, applications and twins, there need to be a common way to share TDs. Directory can serve this requirement by providing functionalities to allow device and twins themselves automatically or their users to manually register the descriptions. Description of the device and virtual device need to be searchable by external entities. Directories have to be able to process search operation with search keys such as keyword from the general description in the device description or information model. We go to the security. Security information related to device and virtual device need to be described in device descriptions. This includes information for authentication, authorization, and payload encryption. WOT architecture should support multiple security mechanisms commonly used in the web such as basic, digest, barrier, and OAuth 2.0. And lastly is accessibility. The Web of Things primarily targets machine-to-machine communication. The humans involved are usually developers that integrate things into application. End user will be faced with the front ends of the application or the physical user interface provided by device themselves. Both are out of scope of the W3C WOT specification. Given the focus on IoT instead of users, accessibility is not a direct requirement and hence is not addressed within this specification. There is, however, an interesting aspect on accessibility. Fulfilling the requirements above enables machine to understand the network-facing API of devices. This can be utilized by accessibility tools to provide user interface of different modality, thereby removing barriers to using physical device and IoT-related applications. So next, we go to the WOT building blocks. This is the relationship of WOT building blocks to the architectural aspect of a things. In a things, we have behavior implementation, WOT scripting API, private security data, protocol stack implementation. And in WOT thing description have general metadata, interaction affordance, data schemas, public security metadata, and protocol binding. Okay, so this is a WOT binding templates. From binding templates to protocol binding and to protocol stacks. Okay, This is advantage and disadvantages. First, we go to the advantage. First, the advantage is increased information linking. The second is efficient searching and global reach and economy of scale. After that, change human interaction, and last is more efficient web browsing. Okay, the disadvantage, have less advanced device will not be able to handle the web. Okay, it can be very complicated for newcomers to understand, like old people that know using of smartphone to assign a web, and employee training and redundancies. Website will seem that much more obsolete, and last is too many of application layers. In conclusion, I can explain what the WOT, fundamental of the Web of Things architecture. We provide a viable framework for users to construct their own WOT device and apps by formalizing the different design aspect to consider. We demonstrate with specific example how different sorts of applications may be constructed on top of the proposed architecture, and we propose how new real-time web method might be used to create web compliant, highly interactive and integrable physical mashup. Finally, we give preliminary performance evaluations and comment to aid future research efforts aimed at making the Web of Things a reality. So, the Web of Things WOT is a study topic that is quickly increasing and complementing the Internet of Things IoT. WOT research advancements have the ability to actualize with a goal. Many prominent technologies, including as embedded systems, web services, IPv6 and tech items, are fueling the rise of the WOT. We highlighted the state of the art in WOT research and address existing technologies and platforms that enable the WOT in this chapter. We show many techniques to web-enable items and simplify the development of WOT-based apps. The techniques are driven by people comfort level while working with the web in order to depict the WOT as a straightforward and do-it-yourself technology, DIY. Advance in communication and real-time systems implied that real-world object will soon be IP-enabled with embedded web servers, allowing them to accessible, control, and composable on the web. We examine ongoing research in this area, which tackles some of the challenges posed by using and modifying existing technologies for pushing and pulling information from real-world items. Many creative concepts and applications are being developed and implemented on WOT to build ambient place where people and real-world items interact seamlessly via the web. We examine to such case studies to demonstrate the progress toward realizing ambient environments, future research directions, trends, and difficulties that are now propelling the WOT into new boundaries. We are also discuss. That's all from me. Thank you. Bye-bye.